The region bounded by the curves y equals x and y equals x squared in the first quadrant of the xy plane is rotated about the y-axis. The volume of the resulting solid of revolution is one of these options. Okay, this should be a fairly standard computation. I never have the formula for these volumes of revolution memorized, but if you understand where they come from, it's pretty easy to either, I don't know if you want to say derive the formula or just sort of write down the appropriate expression. But let's start by graphing these functions. So that's y equals x. Here's y equals x squared. Let me exaggerate it a bit so that my diagram is a little bit more clear. It's not exactly what it looks like, but that's fine. Okay, so we're rotating around the y-axis. So what I'm going to do is I'm going to take a slice like this. And when that area gets rotated around the y-axis, it gets rotated sort of like that. It's going to sweep out. It's going to sweep out a cylindrical surface, and we can compute the area of that surface. So if I call this a generic value of x, the area of one of these cylindrical slices as a function of x is going to be 2 pi x times x minus x squared. Okay, so x minus x squared is that height right there. And where does the 2 pi x come from? Because, you know, a single point on this rectangle will travel, so it's traveling in a circle of radius x. It's traveling around the y-axis like that. And so I have, what I end up having is a cylindrical surface like this, and it has that area. So the volume of the entire shape is going to be an integral from 0 to 1 of ax dx. So I get that the answer is pi over 6 after working through the integral. And that is one of the options. That's option B. So I'm pretty confident that this all worked out correctly. Yeah, there's not much. If you have practice doing these volumes of revolution, then this one really is not too difficult. I never have memorized what the formulas are. And of course, there's, depending on whether you're rotating around the x-axis or y-axis, the approach is a little bit different. But if you understand the geometry of the problem, it's pretty easy to work out what the appropriate formula is for all this stuff. So nice little problem. Thanks for watching.